Let's start the new article that is related to satellite, and this particular article is based on the space physics, and to define these satellites, then it is very easy. You just have to consider any object that is revolving around a planet or in particular around our earth is called satellite. And remember, each planet has its own satellite. So can you give the name of the satellite of our earth? So moon is the satellite of earth because it is revolving around the planet, which means earth. Now here, as the satellite is moving circular path or in an orbital path, so the orbital motion of satellite depends on the gravitational force, by the planet and the initial conditions. So what is the initial conditions? The initial conditions means in the escape speed, what we have seen, the initial velocity or initial speed or the direction of the throwing of an object. So these are considered as initial conditions. Now, satellites can be classified into two categories. So the first one is natural satellite, and the another one is artificial satellite. Now, as we have discussed, the moon is the satellite of our earth, but Jupiter and other planets also have their satellite, and this satellite is same as moon. And remember, this moon is the natural satellite, so it falls in the first category. If we look at the motion or the orbital motion of the moon, then the periodic time comes out to be 27.3 days. And the periodic time of the rotation of moon about its own axis is also nearly equal to 27.3 days. Now, we have studied something about natural satellites, but the first artificial satellite made by Sputnik. So this is made by mankind, and this is the name of the satellite, Sputnik, not K, it is actually here C comes, and that was put into the orbit around the earth. So suppose this is our earth, then it was put in this way around the earth's orbit. So this is the satellite which is keep on rotating around the earth, and this was made by Russian scientists. Our Indian scientists have also successfully launched some artificial satellites. So I am giving you some names of Indian artificial satellites. So the first was Aryabhatta, and then there was a series of satellites, and it is known as INSAT series of satellites. And at present, hundreds of satellites by many countries of the world have been launched. Now, this was about the satellite introduction, but what are the applications of satellite? It is also necessary to understand. So the applications are, or the application areas. If we look at, then they are used for scientific, engineering, communication, also for weather forecast. You can correct the spelling in your textbook, not weather, it is weather. Also for spying and in military purposes. these are the application areas of any satellite. And at present, we shall study the dynamics of satellite. So the arrangement or the characteristics will clear in our mind. And for that I am giving you the arrangement of orbital motion of a satellite. Here I am supposing that a satellite with mass m is launched into the space at a distance r from the center of Earth. So if I am talking in terms of a position vector by taking this center of the Earth as O and this point I am taking as P. So the position of satellite at present is OP is equal to small r, that is the position vector of satellite. Now, its speed in this circular orbit means in the orbit at which it performs the rotational motion is suppose V0, means this is the initial speed and it is also called the orbital speed. V0 is known as, or it is also known as, instead of speed I just write velocity word. So it is orbital velocity. And now here if you consider the total distance r of the satellite, so this will be constant and I can take it is nothing but the combination of height which it has achieved after escaping from the Earth's gravitational field, that is h, and the radius of Earth, that is re. And now we can say that the necessary centripetal force means mv0 square over r, that is which is equal to the gravitational force on the Earth, which is equal to GMEM divided by R square. And so now I can compare this equation. mv0 square over r is equal to GME into m over r square. So from both the sides mm and 1r is cancelled out. Therefore, my orbital velocity is equal to under root of GME over r. And here we can see that the orbital velocity or orbital speed does not depend upon the mass of the satellite. So this is my equation number 1. Now we have seen one case that mv0 square over r is equal to GME into m over r square, and here from both the sides 1r gets cancelled. But we know that the kinetic energy is given by half mv square, but here it is half mv0 square. So my kinetic energy is also related to the gravitational force of the earth by this equation. So it is gmem over 2r. And now the potential energy of the satellite is given by capital U, it is its denotation, and the same equation what you have used in previous theory, the same equation I am using over here. It is minus GMEM over R. So it is basically outside the surface or outside the earth surface properly. Therefore, if I want to find out the total energy of the satellite, therefore that is E is equal to K plus U, kinetic energy plus potential energy, is equal to the kinetic energy we have obtained from equation number 2, that is Gme small m over 2r, and the potential energy I can directly write from equation number 3. So it is Gmem over 2r minus Gmem over r. So the total energy of the satellite is minus Gmem over 2r, which is the final equation, and hence here the total energy is negative, which indicates that the satellite is in the bound state. And we can say from the equations that if the kinetic energy of the satellite is x and the potential energy is minus 2x, then the total energy will be minus x, because E is equal to K plus U. So it is minus x, and hence its binding energy is also equal to its escape energy x by this negative sign only. Now we will study the time period of the satellite.